Next presenter is Jason Hatfield from the Comparative and Molecular Biosciences Department in the College of Veterinary Medicine.
A poultry farmer washes his hands and changes out his boots and overalls in a clean room, standard biosafety protocol, before walking into one of the many identical turkey coops holding 10,000 turkeys that his family's had for 3 generations. He brings in some feed, checks over his flock, and then leaves. Within 4 days, every one of those birds will be either dead or dying, and he'll be forced to cull the birds in order to save the rest of his farm. This very scene is playing out over and over and over again in the state of Minnesota and across the U.S. as farmers are being faced with one of the worst avian respiratory disease outbreaks in nearly a decade, all caused by a virus that most people aren't even aware exists. Avian metapneumovirus is a respiratory disease that has a major impact on the poultry industry. In just the last 8 months, it's cost over $112 million to the state of Minnesota alone, with some estimates as high as $1 billion nationwide. Now, it is important to note that the virus in and of itself doesn't cause high mortality. However, it is extremely contagious and uniquely able to cripple the immune system of young animals, often leading to dangerous and deadly widespread secondary infections. In older birds, it decreases egg production and weight gain, affecting the entire industry. Now, how this virus is spreading into these biosecure facilities, and more importantly, how to prevent it, is the literal billion-dollar question I'm trying to answer. I test how long this virus can survive on common materials found in poultry barns like plastic, cardboard, and metal. I see how different factors like temperature and humidity can affect the survivability of the virus and how easily it's able to become airborne and spread. But my work goes beyond just seeing what this virus does. I'm also actively trying to stop it from spreading using a form of ultraviolet light called far UVC light. Now, unlike traditional UV light, which can cause sunburns and skin cancer, far UVC light operates at a very specific lower wavelength. What that means is that it's significantly safer for both human and animal exposure, as it cannot harm our skin, yet it can still kill pathogens. In my lab, I test whether avian metapneumovirus can be inactivated by far UVC light on surfaces, in the air, and perhaps most importantly of all, how we can actually apply this to real-world settings. If successful, this research could lead to better disinfection strategies, not only for avian metapneumovirus, but other airborne diseases as well, found in both animals and humans, like COVID, influenza, or even the common cold. That's because this is a One Health approach. Because when we protect animal health, we're also protecting human health. In an increasingly globalized world where viruses move more freely than ever before, we need tools that can operate across all different areas of life. And sometimes that tool is as simple and as powerful as a safe, invisible light. Thank you.